Good evening, everyone. I'm Apurva, and this is week 11 of Games and Information. So, there is a question in the chat box. Okay, let me see if I can. If not today, I can explain it in the next session. Assignment.
Okay, ma'am.
Yeah. Assignment 4 is this. I'm just looking at the questions. Okay, so let me share that screen instead. So you're asking question 2 here. Let Q star be an optimal mix strategy for the column player who minimizes U. Which of the following conditions must Q star satisfy for all vertices X belonging to V? Note the sum is over vertices Y such that Y or Y of X it becomes an edge. Okay, so we first need to draw this, not exactly draw. Okay, let me look at it and take it at the end. Till then, I'll have a look at the question and see what they are asking. Okay. If not, if I'm not able to get to this question today, I'll take it in the next class. So let me come back here. Yeah. Okay. So, like I had mentioned last time, this Saturday 6 to 8 is going to be an extra session, which is most likely a summary session. But if you have questions that have not been answered or you still have doubts that you want discussed, you can ask that time also. So that's April 11th, 6 to 8. I'll be using the same link that you used to get to this meeting. So, same meeting link. Most likely, you should get an email for the same. If by chance you don't get an email, you can refer to this particular information. Alright, so let's get started. Let's take a quick recap of the things that we discussed in the last class, because some of that comes up and becomes handy in what we're going to talk about today. So the last class was about a kind of game that is called as incomplete information game. Before that, we had seen games which were called imperfect information games, where something about what kind of an action was taken by the previous player or who played before might be the kind of things that were not known to the players. But the players would still know what is the payoff matrix that they're ending towards, or what is the type of the game. That was the word. Now, this particular last week, we had talked about games where it's the type of the game itself that was not known to the players. So, those games were called as incomplete information games. And we saw, first point, we saw how to think of those games using these extensive form versions. So, sort of try and relate those games with incomplete or imperfect information. Then we looked at a few examples to try and understand what is the meaning of a type and what does it mean. The player who has types will know what their type is, but the other player will not know the type of the player that they encountered, and hence they'll not know the type of the game that they're going towards. But the player who knows the type, his own type, will know the game they're headed towards. So there's a asymmetry in the information available to the two players about what the game is, not just about information of the action of some player, but just about what the game itself is. So their strategies would also be affected by that. Then we saw a few examples of that. Okay, actually, the point that I want to quickly recap is Tackleberg games. So this is the part that actually becomes a little helpful in what we're going to talk about today also. So these are the kind of games, or this is another kind of an equilibrium concept or a solution concept where there are two players. One is a leader, the one who commits to a strategy first, as in if he has said that this is what he's going to do, that's exactly what he does, and the other player chooses his actions based on whatever was the strategy of the leader, not just the action but the strategy of the leader. So that's exactly how this game is defined. We don't have to go through more details of this, but the point is the follower knows the strategy of the previous player, meaning the leader, and hence designs its own action as as just a best response to this. And this kind of a thing happens again when we start talking about things like contracts and communication also. So today we are going to talk about communication and contracts. Just so you know, most of the if you want behavioral strategy questions which is asked in the assignment. Okay, just mention the question number in the assignment and I'll discuss it next time.
Yeah.
Okay, just a FYI, today is more like a summary of this lecture. There are not that many questions or anything of that sort. It's a fairly straightforward week's tutorial, so it's mostly like I'll just take a recap of what was talked about in the videos itself. So if you've seen the videos, this might be almost the same thing. If you've not seen the videos, this can be considered as a summary of what was discussed. Okay, so the main thing that this week is going to be focusing on is communication and contracts. So far, we had talked about games with non cooperative agents. Non cooperative by default means that they will not be talking to each other and hence will not be entering into some contracts. But the moment we get into the regime where agents can be cooperative, that means that they would be willing to share some information with each other, meaning there can be some form of communication and there can be some contract signing as well. So, this is the kind of problems that we are talking about today. Sort of cooperative. Okay, so the main things that I'll discuss are these principal agent models. These are very similar to Stackelberg equilibria concept. Then there are these things called moral hazard and adverse selection. And last, I'll talk about contracts versus communication. This part will very briefly introduce what are called as correlated equilibria. Correlated equilibria concept will come up in more detail in the next week's tutorial by default. If you have any questions, put them in the chat box and I'll take them in the session on Saturday, this Saturday. Okay, so let's get started.
Hey, I actually did not see an email for the Saturday session.
You received an email?
No, I didn't. But you were asking in the last lecture, so I thought I'd confirm
I
you.
see. That's the part that I'm also not sure about if you're going to receive it or not. But either ways,
Okay.
these are the details.
Oh, okay, got it.
Tomorrow,
Same with you.
not tomorrow, Saturday, same time, same link.
Got it. Okay,
Saturday
sure.
is 11th, yeah.
Okay, sure.
Okay, so let's get started. first of all, let's recap that we saw these things called dynamic games, where some information would be known to the other player, meaning if I played first, what action I took may be known to the player who plays after me, or I will at least know that okay, this is the player who plays after me. So something is being passed on, but that is not what is being referred to as communication in the framework that we are talking about. Communication has to be some sort of decisions that are not directly going to affect the cost. There may be an indirect effect to cost that's obviously going to be there, but there won't be at least a direct appearance in the cost, direct effect in the cost. Meaning, if we use the word decision, if you look at the word decision, it refers to two particular cases. It one refers to actions, which we have been talking about so far, and these actions are the things that come up in week 9. Okay, wait, I'll note that down. That was week 4, question 2 and 7. Specifically, how did they make the graphs? Okay. What was I saying? Okay. So, typically, when we talk about decisions, decision can be in two different forms. One kind of decision is the standard ones that we've seen so far, are like actions, and actions are the ones that appear, or it's on the basis of these actions that there is a cost assigned to each agent or the tuple of agents that are in the game. The other kind are signals, or the kind that we saw in sender receiver type problems. Uh, what we saw before, Stackelberg, that was also a kind of a sender receiver version only. The leader was making some decisions based on whatever information the leader had, and in the process, if it played first, committed to a strategy, and once it has committed to a strategy, it is sending something to the receiver, and the receiver or the follower in that case would take an action based on whatever it received or whatever it is seeing, which is the strategy, and that in an abstracted out manner can be thought of as a sender receiver game also. So here what is passed on from a sender to a receiver is some information, some signal, and this signal directly will not have an effect on the cost of the utility or the pay of the game. This is incorrect. So these are sometimes called as information carriers, signals. So when we talk about communication, what we are referring to are these objects, things that do not actually affect the cost or do not directly lead to any change in the cost. So one particular example of this kind of a communication, the simplest version that we can think of is, suppose there is some information, a sender receives that information and he passes it on to some receiver. Receiver got whatever it is here. The receiver doesn't have information, the full information. It only knows what it received from the sender, so whatever is here. And based on that, he's supposed to take his action. So this is in a way, now the sender has an upper hand because he got to see the full information. He decides what information, what part of it is going to pass on to the receiver. So maybe we can just start using the word signal here. What signal is he passing on to the receiver? Because ultimately the receiver is going to take his action or play a strategy which will directly affect the cost, is going to be dependent on what he received, whatever his input was. And this input is something that is being sent out by the sender. So in that order sense, this is similar to what we saw in Stackelberg game. Like in Stackelberg, what was happening was the follower committed to a strategy first. So there was a strategy by the follower. No. Sorry. The leader committed to a strategy. Now, whatever this strategy was known to the follower, and the follower used this strategy to choose his own action. So if this was the action of the follower, he would be using this information, and that will ultimately affect the cost. In Stackelberg, this might actually be something that is important in the cost itself. So the cost that we saw was with respect to the strategy and UF of strategy. But in the kind of way we are talking about communication now, this will not show up in the cost. Okay, that's the similarities and differences between this and Stackelberg. Okay. Any questions so far? Okay, if not, let's continue. Okay, Vivek, why don't you write all of them in the chat box? I'll note them down at the end.
Yes, yes, yes.
Yeah. Okay. So let's talk a little bit more specifically about the kind of situations that are possible with sender receiver games. So one of them is these. Uh-huh. Oh, it's the same thing. One of these are these things called as principal agent examples. This is the kind of thing that comes in contract theory, where so the word contract means that two agents are deciding whether to agree to do something, and in that agreement, are they, once they've agreed, is there some clause or something that makes them restrict themselves to actually believing going with that contract, or even after signing that contract can they not necessarily have to follow what they have signed for. So there may be a penalty clause in the contract itself, but how is that enforced? So we're going to look at some very simple examples to try and motivate these things, just a little bit to see that how this still fits into the framework of game theory and how this can be modeled as a game. So let's take this particular example. So here, principal is the first one, agent is the next one, or in other words, I said it the opposite way actually. Agent is the sender, so he's the player who has all the information. That's why he's called the informed player. And principal is the receiver who is not informed about everything. So one example that you can think of while looking at these scenarios is there is a manager or a HR person versus an interviewee, a candidate who has come and is just deciding whether to join a particular firm, firm A or not. That's all this is. So this principal is the HR or maybe the manager, and this is an employee. So the scenario in this game is, the easiest scenario is principal has full information. That's the case one that we're talking about. What is happening here is this agent, based on whatever efforts he puts, so E, let's say, refers to the efforts that he's putting, then he gets a wage. The principal offers him a wage depending on his efforts, and since principal is offering a wage, in this particular scenario, the way it is designed, he can see the efforts of the employee, meaning he can see once this person is employed, maybe there will be a way to know, okay, for how long they were logged in, or for if it's a salesperson, what all places did they visit today, for how long did they stay at client A's house and then client B's house, and so on. So this is a scenario where principal has that kind of information, so he can see the efforts through whatever apps or processes or whatever, but he can see all of that. That's why we're calling it as full information scenario. So now this is the step one of the part, that principal will offer some wage to the agent depending on the agent's effort. The agent will actually be putting in efforts, doing the tasks that are delegated to him, but he'll get a wage according to that. That's this part is part of the contract. Now, since it's a contract, for the agent, he still has an option to decide if he's going to accept the contract or not. He still has that freedom. And since he has that freedom, whether he's going to accept or not, it becomes like his core actions in this game, where the HR or the manager would want to hire him, and hence make sure whatever are his conditions are met, and at the same time want to ensure that, okay, week 5, okay, huh, yeah, so the manager or the principal would want to hire this agent, want to make sure if they have some constraints, some restrictions, some non-negotiable things that they want in the contract, they will try and make sure that they can live up to that. And as a result, based on what they expect the efforts of this agent will be, they'll offer him a wage. So if so in the two scenarios, if the agent actually accepts the contract, then for him the task would be to decide how much efforts he's going to put in. If he decides to reject the offer, then there are no further steps. That's where this part of the contract game ends. But if he does accept the offer, he's deciding what efforts to put in. So this effort and the wage are like the two sides of the coin, and there needs to be a kind of a balance, and that's going to be the solution of this game. So here, so now let's say there is some sort of a value to the principal. So maybe if it's a salesperson, if the agent is a salesperson, if they put in efforts, it brings the principal a total clients of some number which depends on the amount of effort. Meaning, we're taking very simple scenario where if he puts in more effort, if he talks to more people, he's going to likely convert them to actual clients of the company, and hence convert into revenue for the company. So in that case, what happened is the payoff that the principal received is some function on the value of this agent's effort minus whatever cost was incurred by employing this agent. So principal would want to make sure whatever value he is getting is ultimately maximized. Right? This much we can see at this stage also. Further, it's the agent who needs to now decide what to do. Agent in this version of the problem is the sender, right? So he gets to decide what actions he does, how much effort he puts in, and his efforts will translate into some kind of a wage for him. If he is willing to put in a lot of efforts, he will get a good wage. This can be thought of as a salesperson getting commission. There are some fractional commissions that people get if they get, say, X number of clients. That might be the requirement for that month or something of that sort. So ultimately, what he would want, the agent would want, is he should get as high a wage as possible. That's a natural requirement, but at the lowest amount of effort. So he doesn't want to expend effort like anything. He doesn't want to spend all 24 hours a day just working and get a very small salary. It's the exact opposite scenario that he would want. He would want a good enough salary at basic bare minimum efforts of his comfort. So that's the kind of requirement that he has. Okay, and at the same time, if you know, whenever a candidate comes for an interview, at the time of negotiating, even before interview starts, there would be an HR round, or HR just talking to the candidate to sort of get an idea what are their salary expectations, or what do they want, what utility do they want. If that is not met, they're not going to join the company. So that here is modeled in the game as this U bar. This is the reservation utility, or just the cost of participation, that if this is met, then the agent is going to participate, otherwise the agent is not going to participate. Meaning, this could be like a couple of things, like the agent could say that I am willing to give 8 hours a day at so and so salary. If these two requirements are both not possible to be met, then he may decide, like there may be a utility function on top of these two things, his effort and the wage, and that gives a value to what he's willing to give, what his reservations are. So whatever utility he gets from joining the company should by default be more than this U hat. Okay, so this becomes the constraint of the problem. This is something the agent wants as a requirement from joining the company itself. And if he decides, if this is met, then for him what is left to decide is this E. And in that scenario, the wage that he'll be given, now think of it from the perspective of the HR, the wage that this person will be given doesn't have to be way more than this. They can just match this wage and be done with it. And that's exactly the bare minimum utility that the agent is going to get. This is what they wanted, and that's what they'll get as a optimal wage. Yeah.
So can you explain the meaning of utility over here? Like
Meaning
what
of-
do we mean exactly by agent utility in this case?
So this is like saying what kind of efforts will he put in depending on the kind of wage he's getting, or considering both of those things, what is his maybe like a satisfaction score from joining a company.
Okay. And it's a function of these effort and wage, right?
So if you're okay to think about it in a slightly subjective manner, then you can think of it like a work-life balance kind of a rating that you can give to any company based on the number of the number of hours they expect you to work. Let's say they have a strict login and log out time, and you have to be present even if you don't have any work. You have to be present at that time, and they're offering some X amount of salary that depends on this E. So if you
Okay.
take a half day, that gets deducted and all of that, for example. Then based on that, what kind of a satisfaction do you have in a balance between your work and your personal life itself? Maybe that kind of a thing is quantified into utility.
Okay.
Okay. Like the easiest way would have been to think of salary expectations, as simple as that. But since this utility is a function of E and the wage, this is slightly more than just a salary expectation. This is expecting
Got
more, maybe work growth, maybe work life balance, but quantified in some way.
Okay. Yeah. Makes
Yeah.
sense.
Okay, so what the so what the HR or the principal does here is, this is what he offers. He says, okay, since this is what you require the utility to be such that the utility is greater than some U bar, then I'm going to give you a wage W star such that these two are exactly equal. And that's it. Equality already works for the agent. That means with the bare minimum from the principal side, he got the player to start working. Now, once the agent has started to work, he has a choice of how much effort to actually put in. He knows that his wage is going to get affected by the W function, and it depends on his efforts, but it's his efforts that he can still decide on how much effort to put. And hence, because this E is still a open factor, the payoff that the principal will get will depend on maximizing this utility with respect to the efforts of the player. So the principal would want any manager wants their employees to work as much as possible. They're never happy. They want more and more and more. And that's pretty much captured by this. Even though getting work done is not in the hand of a manager unless they themselves start working or maybe micromanage. But still, it's the effort of the agent that will decide how much utility that they're going to get. And that's what they want to maximize. And in the process of maximizing, they still want to make sure that the wage that is offered is not way too high from their expectations, based on some utility criteria, or what they're calling as a participation, or a reservation utility, or just a participation fee of a kind. Okay, so this captures the simplest scenario, the scenario where player 1 or the principal player has full information. And this full information made an important effect here because he knew what to expect. He gave the wage to be such that these two utilities match. And once he did that, the efforts are actually in the hands of the sender or the agent, and hence maximizing his own utility depends on how much effort the employers work for. Now let's take the other trivial case. Uh, okay, I think this other case that I am referring to is if I have not written it. Okay. So this other case that I'm referring to is if the principal does not have an access to his efforts. He can't see how much efforts were made. If he can't see the efforts made by the person, he can't be maximizing with respect to E. He has to be doing the optimization with respect to whatever is possible. So if that is the case, no. Sorry. Okay, this one is talking about presence of a participation amount. Okay, if suppose there is no U bar. Right. So if there is no U bar, what happens in that case?
Then even without giving any wage, the agent will be forced to work.
Exactly. If without giving anything the agent is willing to work, then you can sort of push it and get the agent to pay you instead. Slavery, yeah, exactly. So in that case, if that happens, the payoff for the principal would be the plus wage, meaning it will actually become something infinite. So for the principal, it's very useful, but it's for the security of in a sense for the agents that it's better that they have some sort of a participation amount, that they don't by default agree to an agreement, or rather they should at least have the will to agree or disagree to an agreement. Okay, so this is the other extreme. Okay, now another scenario is if okay, I said that before. Now the other scenario is if the principal can neither see the efforts nor the outputs that can be produced. So if the principal cannot see the efforts or the output that was produced as a result of the efforts, then we can say that one way would be to give a constant wage. So the utility, so this is the utility for the agent, right? So the utility for the agent is efforts and some constant. So what is the optimal thing to do here for the agent?
He will do like the optimal effort would be zero in this case. I will do the minimum effort required to reach as much utility as possible. I think.
Exactly. if he's getting a wage and that wage is not dependent on his efforts, it's very natural that he may choose not to work at all. And in fact, the optimal thing for him to do would be to do nothing. And if he does nothing, uh, this quantity will be very small. So, this kind of a scenario where the player, even though enters a contract, meaning he has agreed to work for this particular manager, but because of the way the contract is, nothing in the contract is ensuring that he actually delivers what he promised to deliver in a way. And hence, he can just put in no efforts and get away with it. And this is called a moral hazard. And this is because the agents, the principal cannot observe. If the principal could observe, he would try to get the player to get the agent to work. Would have some ways to bring in the effect of efforts into the wage itself, some function or something.
Right.
Okay, so there are a few other scenarios possible. Other
Here
scenarios.
also, sir had mentioned that then in that case, the principal can reduce the salary. If I mean, at the end you had mentioned, but my question to that was that anyhow in this case, when the principal would offer constant wage to meet the principal constraint, then that would anyways be the lowest possible wage, right? Uh, so
That is
initially
true.
only he would offer the lowest possible rate, and then the agent would do almost zero work because that is not needed. But then sir had mentioned that the principal may reduce the salary, but as such, that will all be the lowest. Right?
So what you said is correct. So here, once an agent enters this kind of a contract, it is optimal for him to not actually put in efforts. And
Yeah.
this is something that the principal would have easily analyzed and reached at. He would have been able
Right.
to see, because I'm offering a constant wage, he's not motivated to work. And hence, nothing is stopping him from actually reducing this wage itself. This wage was something that was decided by the principal.
Right.
So he could reduce the wage. So now what is happening is the wage is reducing, the efforts are by default zero. So that is not changing. If you principal keeps on decreasing the wage, that just comes to zero. And then you
Okay,
can
but like when the principal reduces the wage, then he would have to take care of the participation constraint in
Huh.
every time, right?
Yeah, he'll have to take care of the participation constraint.
Okay.
The moment the participation constraint vanishes, that's where he'll have to stop. But if suppose that wasn't the case, so if there wasn't such a bound, then he can, right? See, anyways, the agent is not working or not putting in efforts, and hence we can assume that the participation amount that he would be expecting would be fairly small or maybe negligible, maybe zero itself. Just anything better
Right.
than zero is what he would be happy with.
Right.
So
Yeah.
in that sense, sir had said that the principal would also end up reducing the wage in response to what the agent is doing, because this
Yeah.
is like
Okay.
a cyclic situation. They're both deciding their action based on what they know and anticipate what the other would do. So it's like their action depends on their strategy, but like a best response to the others. So in that sense,
Yeah. Makes sense.
yeah. Okay. So another scenario is if the wage, instead of depending directly on the efforts, depends on some function of the effort. This one is easy to understand. Efforts can be thought of as like the number of hours an agent works. Instead, instead of thinking of wage as something that depends on the number of hours they work on, we can think of wage to be something that could rather be dependent on how efficient they are in producing an output. Or if we were to go back to the example of salesmen, number of hours does not necessarily mean that they'll get a client out of the person that they're going towards. It's the number of clients that they get at the end of the day that matters. So this kind of a function, q of e, could be something that captures that. And if an agent gets some x number of clients, let's say that's what this q of e is, then the wage should be dependent on that. So that's another scenario. So if that is the kind of scenario we are talking about, if the wage depends on this, then principal can just know what q of e is. He would be happy to just know this function. And if he knows this function, then what he would be doing would be trying to maximize this q of e. So it's still, keep the salesman example in mind, he'd just be trying to increase the number of clients he gets from this agent, and his utility, which was something that depended on this q of e by default, and the wage of minus the wage of the agent. So this is what he'd be ultimately trying to optimize over. We could write it in a slightly more simpler way, but doesn't matter. This is still showing us that efforts have a dependence, but the layer that actually matters is this function. And yeah, one example could be, this could be number of hours, this could be number of clients. Okay, so this is still not a trivial case, that there is something that can be done. Now this fourth one is the most realistic way to think about a wage. And this one says this function q should definitely depend on the efforts put in by the agent, but at the same time it should be dependent on something random, something that is chosen by nature. Now if nature is coming into play, a lot of different variations are possible. Does the agent know the actual realized value of this theta? Did nature play first and give its realizations, and then the agent played, and then the principal played? Like, all of that ordering becomes important, and actually that will come up in the next part. So this is the next scenario where the wage depends on the efforts and a kind of a luck factor. And since the thing that principal would be ultimately trying to do would be to maximize this object, yeah, this object, but now this object depends on theta. Yeah, here this theta is some probability distribution, let's say, and is coming from some probability distribution, some probability distribution which is common knowledge. So let's say both the agents actually know this, but they don't know the realized values. They may not know the realized values. That's the key part. So again, in this case, the principal would be getting a value. His utility value would be something that depends on the actual wage of the other player. This value of the efforts of the other player minus the, or some function of the wage of the agents. And once we take an expectation over all of that with respect to theta, obviously, or whatever is the variable for theta, let me just call it p of theta, whatever that is, and maximize that over the wage, what we get here is the utility for the principal. And hence, in a response to this, for the agent, the best response for him in this scenario would be to put in enough efforts so that this object, the expected utility, again taken with respect to some p of theta, of this object e comma w, which depends on q, which depends on e and theta. So a lot of dependencies are there, some implicit dependencies in fact. the argument of this value, the expected utility for the agent, whatever that is, will give us E star. That's the amount of effort the agent will be willing to put. And hence, because this is the utility for the agent, because we're now talking about presence of some uncertainty, and hence expectation is what we should be taking, the participation constraint would be this should be more than whatever that u bar is, whatever is their reservation. And another way of saying this is in a way saying that the agents are individually rational. So right now we're talking about only one agent, but we're just saying that they're rational enough in choosing their u, choosing to even become a part of the contract if this condition is satisfied. Once it is satisfied, what actual e to play is for them to decide by taking the argument of this. They're still going for the bare minimum effort that they should put in, but still put in that bare minimum effort. And once they've put in that bare minimum effort, the wage is decided by the principal in the process of trying to maximize this object. So they're sort of all very interlinked objects to each other. Okay, so now, just like I was saying, because we have introduced presence of nature, it matters what is happening. Is the theta something? Okay. Is theta something that is getting realized first, and then the agents are putting in efforts, or is it the other way around? Is the agent even aware of what this theta value is? The realized theta value. Distribution they know. But if they know the realized theta value, he could very smartly. So, in a scenario where the agent knows what this theta value is, the realized theta value at the given point of time, if he knows that, then he can be like, okay, I'll put in only the needed amount of effort. So, in that case, he could say that my E could be something that depends on that theta. Maybe all he cares about is reaching a certain number of clients. Luckily, he ended up meeting people who became his clients. He sold whatever he was planning on selling, and that is already done. Now, from the quota that he has to meet for the month, he has a remaining number. So, in that sense, now he needs to only put in efforts to reach that number, and hence he can consider his efforts to be something that depends on theta itself. So that becomes a even more convoluted set of way of dealing with the contract, and hence the amount of efforts to be taken in that contract.
Makes sense.
Yeah.
And like the agent wouldn't have an idea of probability distribution as well, right? For theta.
Probability
Until unless.
distribution we would know by default. That's
Okay.
the case that we are considering. Actually, it is possible that this distribution is also something that's not known. That's the example that Sir gave, where this theta distribution, this example of wind energy distributor and all of that, this theta distribution was something that was not known. This was first being estimated by the agent. Agent was the one who was distributing the energy. So they were looking at whether there was good amount of wind that particular day, and if that led to creating enough energy through windmills, for example, and if that was enough to distribute to the, well, whoever was the buyer for that plant for maybe that year or something like that. So first, in that problem, they were estimating this theta. Once they have an estimate of theta, then they were looking at were their realized estimates good enough to actually take care of how to distribute, how much to distribute, and so on. So,
Right.
in certain examples, more difficult ones, this theta, we might not know the probability it's coming from.
But in case we know, then we can just simply see that how much effort will be required, how much will be compensated by the theta, and how much will be the
That's
effort we need to put.
definitely one way to think about it. But the typical assumption is the following.
Okay.
We assume that the agents don't know that theta. They don't know the realized value of the theta when I say they don't know theta. Because
Right.
we don't want this kind of a scenario to happen. We don't want the So what this will do is the agents will become dependent on luck, and in the process, their productivity, their sense of integrity towards their work is actually going to go down. So it would be nice if there was a way in the contract itself to make sure that they don't have access to the realized values. The realized values do show up, but they
Okay.
show up after they've already put in their efforts. So that
Okay.
way, the company would at least be like, okay, they are putting in efforts. Whether it's giving you the needed output or not is different, but they are hardworking people. So it's in a way sort of pushing towards people being hardworking.
Makes sense.
Yeah. So the reason why this particular tutorial is a bit more theory side or just subjective is because these things are more towards economics and contract theory and all of that. And from the point of view of game theory, these models are very much aligned, but it's a subject of a much deeper study that this course will not get into, and hence this is just like very surface level.
Right.
Okay.
General game theory would consider all these factors.
Sorry.
General game theory wouldn't consider all these factors. Be very specific now.
Yeah. So the whole point of showing all these things is that the framework of game theory that we have seen so far actually is general enough to deal with these problems of contracts, or it's able to at least model them in a decent enough way. And even the problem of communication can be modeled through game theory itself, which sort of builds on the point that okay, this is general enough, it's a good model. Where to use it, what to do with it, and whether to actually use it in a realistic scenario is a different question altogether, because we've already seen that these problems are very hard to solve for. Finding an equilibrium may not be the required thing. We might be more interested in taking the sum of the utility for the two agents or something of that sort. So this may not have a what do you say, an application that a large scale application, okay, a large scale real world application may not be there, but as a theoretical study this is still valid, and this is in fact used in a lot of consulting firms, a lot of insurance type policy designs and all of those problems. In
Right.
fact,
Makes sense.
this is also, these kind of things are also used when people talk about auctions. There are
Okay.
auctions or bargaining. There are sort of chapters and a lot of research in that area as well.
Right.
Okay, yeah, I'll continue. So yeah, I think I've already said what this example was. So sir gave this example. So in this example, let's say there's a windmill farm where electricity is getting generated, and a particular firm is deciding whether to buy their electricity for their need for a year, for example, from this wind farm or not. And to make that decision, they are just trying to see if their efforts in estimating uh, the luck or the uncertainty in the problem, if that is good enough, and in fact if that can be first of all quantified, then it's a good idea to go for the contract. Otherwise it's better to rethink. It's roughly that kind of an idea, but here, because it's to deal with distributions, it's only when you see something, if you only look at enough number of samples, then you can have a estimate of the distribution itself. Only then the principal or the agent, in this case we are considering ourselves as the agent, and the distributor, the energy distributor is the, or the windmill farm is the principal. We will have to look at more than a few samples of what they do with whatever data they received and how they give electricity to decide whether to actually go for it or not, which is a very counterintuitive idea, because if it is not good, we're stuck with them in a contract, even if they're not good, and we only got to know that they're not good after actually entering a contract, because otherwise you cannot know it, because it's a probability distribution. So these types of problems where this distribution, the the distribution with which this theta, the luck factor, is generated is not known, makes the problem even more complicated. And in real scenarios, for example, in scenarios like energy distribution, this creates a lot of issues. Coming up with contracts here in these types of scenarios becomes an even more difficult task, because you're ultimately trying to see if whoever it is that you're getting into a contract with is doing the estimation properly, and if their estimates are just point contacts, or point estimates, or of the whole distribution, and even if they have the estimate of the whole distribution, is it actually the same as the true distribution? If they have that, is the output that they're giving matching what you would have expected if they actually had the true distribution itself? So this makes the problem fairly complicated to deal with as soon as there is an uncertainty brought into picture. But again, at the same time, this makes it more realistic, so worth discussing. Okay, so this gives us a few different ways of looking at what happens when there is presence of nature. So let's say, for a easy example, let's say nature, all nature is doing is either giving theta with a high value or with a low value. So this can lead to a few different problem classes. The first one is a moral hazard problem with hidden action. So here, principal gives out a contract, the agent decides whether to accept the contract or reject the contract. If it rejects, game is over, there's nothing to be done. At the next point, it takes the effort. Now these efforts are what are hidden to the principal, that's why we're using the word hidden action. Agent takes some action, puts in some effort, and nature gives a realization, and the added is the outcome. Maybe it's the outcome that is visible to the principal. Now if that is the kind of scenario, then the principal would try to make sure the contract is such that if the player decides to enter into it, meaning the participation constraint is met, if that is met, the efforts that the player the efforts that the player actually does are good enough to give them the required value that they want from the agent. So whatever QE they wanted, hopefully they're able to get as high value of that as possible, or maybe the utility of QE and wage. Okay, so
But here Q is dependent on E and theta both, right? N is coming into the picture.
haha.
Yeah. Okay.
So this is the scenario where the wage would be something that is dependent on, this is from the above only, so wage would be something that's dependent on a function, some value, and that value itself will depend on this E and theta. So this is the theta part.
Right.
Yeah, I did not write the thetas in here. Better, yeah. Okay, so in such a scenario, because the efforts of the agent are not visible to the principal, there is a possibility that the agent doesn't actually put in the efforts that they sort of promised while showing their skills or so, uh, while entering the contract, and hence this can be a problem of moral hazard. Now there is another scenario possible, which is if the agent can observe the state of nature, or can actually see the realization of theta. It's like the salesman example, where the salesman went to a networking event by mistake and ended up meeting a lot of people and converted them into clients very easily. That's a luck factor. So in that case, he would know whether the luck factor is a high luck factor or a low luck factor. So he would know which realization of theta he's in, and based on that, now he can decide what to do with his efforts, how much efforts he should put in further on. If that happens, this part, as in the actual realization of nature, would not be known to the principal again. And this is a part where there is some hidden knowledge, something that is hidden from the principal. And this is all happening after contract. So this part is definitely the after contract thing. Okay, so the core difference is this realized by are these two distinguishable by the agent or not? If in the scenarios they are distinguishable, then two cases emerge. One is where there is a moral hazard, that is, the agent might not put in enough efforts, assuming that okay, nature would put in the needed efforts. The other scenario is if the agent knows something that is not known to the principal. In this case, it's the realization of the nature's random assignment or luck factor. There is a third scenario possible. So, in that third scenario, it starts out with nature itself. Nature gives one of the two cases, but principal cannot distinguish between what is the realization. Nevertheless, he makes a contract. Agent goes further with the contract. See, the way we have made this diagram, does this agent know whether it's high or low uh, value for the theta?
Doesn't seem like.
It doesn't seem like it, right? A only knows what P knows because there's just one line here, there's nothing else. So A barely knows anything. So even A cannot distinguish between high and low. So what is happening here is something is getting created, and it is getting created before the game even started, if before the contract even started, but it is something that's not known to either of them. In that case, the kind of selection that is the kind of game that is happening, or what is happening in the contract, it is called as adverse selection. This is the scenario where the player is playing first, nature plays first, but principal does not know that, and he makes a contract without knowing this. An agent just accepts or rejects it. So this is, in a way, can be thought of as insurance example. So insurance example meaning principal is the one who is trying to sell the insurance, is the insurance seller or the salesperson, and agent can be thought of as the client, because when a salesperson goes to a client and tells him, you know what, I have this so and so insurance policy, would you like to buy it? So the contract is visible to them, this is visible, but here the principal doesn't know the state of nature. And one way to think about the state of nature could be the principal doesn't know if agent has some illness. Maybe that illness is not even known to agent yet. It is there, but it is not known at the time of contract. Typically in health insurances, if the agent is aware, he is required to mention all the terminal or chronic illnesses he has. But if there's something he himself doesn't know, he can still get into a contract and only realize at a later point of time that he had something. And whatever contract he does enter into, it should be the optimal one given what he would require in the future. That's roughly the idea people have when they're trying to buy or sell insurances. So this is an example of this is what is called as adverse selection. Okay. Yeah. Okay. So there are a few more scenarios possible. Just give me 1 second. Just 1 second.
Sure.
Okay. So there are games of this kind also. They're called signaling and or screening. In these scenarios, what happens is, let's say there is, let's say again there is nature who gives some random values. These random values are not known to the agent, and in fact they're not known to the principal either, but they're there and they happened before anything. But the agent sent some signals, sent some information to the principal. So maybe they talked about something, whatever that communication may be. So maybe in the previous example itself, we could think of it in the following way. Uh, Before this scenario happened, this is sort of extended a little bit. Oh no, this is not going to work. Okay, but I can still think of the example of insurance. I can think of it in a slightly more stronger way, think about it in a few more details. So maybe uh, A is our client, P is the one who's trying to sell an insurance, a health insurance policy, and agent A may have some illness. He doesn't know which it is, but he does tell him, okay, these are the things that I have, these are the things that I don't have. So he has given some information to the principal. Now, based on that, the principal decides what to do. Either he can take an action. He, based on whatever he heard, he can see, okay, based on what you're telling me, I have two policies that I have two contracts, two insurance policies that actually fit the requirements that you have. So these are the two options. He can give those options. Here, only one is captured, but he can give those options. The agent could see those options and decide whether to accept them or not. Or he could decide that, okay, based on your requirements, we don't have a policy currently, or we don't have an available contract, and hence he just decides to leave. So either he can take an action or give a contract, or maybe give an option of a contract. He can decide to show only one contract, whichever is beneficial for him to show, because maybe there is like whatever contract he gives them, or whatever policy he gives them, and they actually end up buying, he gets a commission out of it. So he might have some targets to meet, and hence might be inclined towards one policy as compared to the other one, which might be close enough for the requirements of the agent, but for him, they make a difference of commission or no commission, or low versus high commission, or something of that sort. Okay, so this is an example of signaling. So the example that I repeated is of insurance again, where the client sort of gives history, gives some amount of history. Okay, now let's look at this scenario of screening. This is the scenario where the principal doesn't know what the state of the world is, or what nature has done, what has happened here. He decides to give a contract. The agent decides to accept or reject. The agent doesn't get. Okay, that's actually about it. So this is the standard way of going about. Uh,
In this, Sarat mentioned something like the principal commits first. And he had mentioned that the diagram, you can refer to the one which is for signaling, and there only we can consider that the principal commits first. Something like that. I was also not very clear with.
okay, I see. Okay, that's why this diagram, the screening diagram, and the diagram that we saw for adverse selection, actually seem the same. I see. Okay. Okay. So maybe this arrow type thing means P commits first. The idea of screening is to decide whether to consider A or not. That's roughly the idea, and this is the part the principal anyways doesn't know. So he's making that commitment maybe beforehand. That's what it's trying to say. But this diagram is not very helpful to show that actually.
Yeah, he had said specifically that refer to the diagram for signaling as it is, but just the difference that the principal commits first.
So that only happened, right? It's the order that has changed.
Yeah, okay.
No, so the thing that I'm a
okay.
little confused about while looking at these diagrams is this. Can you see whatever is written for adverse selection is the same as what they have for screening? Is okay. I'll check this and take this in the summary session next time. So Saturday.
Sure. And in the first two cases,
Slide down.
like this one, the moral hazard, the hidden actions, and the post-contractual hidden knowledge. In both of these cases, the principal is not aware of the nature, anything that the nature does. That is only knowledge to the agent, right? So, like
Yeah,
in the second case.
yeah. So
Yeah,
in the first case, even the agent doesn't know because it's happening after.
right.
But here,
Yeah,
because nature is playing first and we have not drawn a information set here, so agent does know what nature gave, but principal doesn't know in either of those cases.
yeah, okay. Got it.
The thing here was, it's in this particular case, the principal would actually get to see the combined result of effort and whatever is this theta, or rather he would just get to see this q value.
Right.
So in that sense, for him, what action was taken was hidden. The action is actually still hidden here also, but along with
Mhm.
that there is some hidden knowledge also.
Right, right.
Yeah. Okay. My sir has talked about moral hazard even in more detail, so let's go through that now. Okay, this is just getting a bit more formal about these things now. So in moral hazard, so what we see is, this is with hidden action na? So let's say there is a manager and a worker. Sorry. This is the effort of the agent. This is the noise factor, the luck factor. This Xi is the wage, the payment made by the principal to the agent, and this is something that depends on, it's some function of this x value. So this is the uh, the total effort, so to say. So this is an additive situation. So you can take the example of the salesperson, that this is
Yeah, I think the A was the effort and
A is the effort.
X was the output. Yeah.
Yeah, this is the output. So you can think of this as the clients he got by actually spending time and getting them. This is some luck factors that happen. Maybe some relative called and was like, oh, I wanted to buy this, do you know someone? And that kind of thing happened. So overall what he got, what output he produced is this x. So in this scenario, the participation amount or the reservation utility for agent A, or for the agent, would be to, what is this CA? This is his utility given whatever wage he got, minus, okay, the cost of taking that effort. This could have been written together also. We could have easily written this as UA of Xi. This is the payment, the wage.
Output
And
minus wage.
yeah, and just A itself. C is not defined, that's what I'm wondering. Okay, anyway, so what he's supposed to do for participation is just to make sure that this quantity is greater than equal, or for him to decide whether to participate or not, is just to check if this quantity is greater than or equal to his reservation utility. And on the other side, the principal's problem would be to take the expected utility, take his expected utility, and his utility depends on this x and the function, the wage sort of, and all he's supposed to do is just maximize this quantity for all the possible wage that he can offer to the agent. And in the process of trying to do that, he's going to consider this as a constraint to his problem. So all he's required to do is solve this optimization problem. If he can solve this optimization problem, he can decide what kind of wage to offer. So his answer or the thing to take from here would be the wage. Argmax of this should give us the appropriate wage that should be given to the agent, and given that wage, sorry, the player would just decide what is the minimum effort that he should be making. Hmm. Okay, so the moral hazard in this problem is in the sense that even after getting into a contract, meaning this condition is satisfied, the player got a wage that depended on his effort, but the efforts that he took were much less than what the contract expected him to take. So there is another scenario possible. Um, this is the standard scenario, which is a worker is working on their own. Another is if, in some sense, the agent or the manager decides to sort of micromanage, pinpoint at every work that, do this like this, do this like this. And in the process of trying to micromanage, what happens is he, the agent, sorry, not the agent, the principal, not only keeps observing or keeps looking at the wage or the payment that is being made, but also looks at the kind of effort the agent would be willing to put. If a agent is willing to put enough efforts, he will give a contract accordingly, and the contract that he'd give in this particular way would be such that this participation constraint is still satisfied. So when this happens, whatever utility that we get would by default be greater than the utility we would have gotten in this game.
I'm not even, I don't remember it that well, but I think it had something to do with action also, or not in
Uh-huh.
this case.
Yeah, the action. Okay, the word I was using was effort, but yeah, action.
Okay, okay. Yeah.
So what is happening is the principal is not only looking at the wages or not only affecting the wages, he's indirectly affecting the actions or the efforts also. It's almost as if saying that he's himself doing the work, sitting on someone's head and making them work, almost like a micromanager. That's as if they're doing it almost themselves. That's why it's called this FB. And
Okay.
hence, whatever utility that you're going to get from here is going to be a better uh, utility from the principal's perspective as compared to what he would have gotten without micromanaging. Okay? And the gap between this utility and this utility, is what is called as information rent. And this just refers to if the principal himself was to do the work that he is delegating to an agent, how much of the utility is he losing in the process? And of course, how much of the information he's sort of letting go and not using in making the contract itself. So it boils down to this can be achieved in an actual scenario. This can be achieved if the agent is obedient. If the agent is not very obedient, it, it will, the actual utility value would be closer to VP. If he is obedient, it will be somewhere over here. But this is the range. So VP to this one. These are the utilities that are to be expected.
Right.
Yeah. Okay. So right. So we have talked about. Okay. Now let's talk about this adverse selection in a little bit more detail. So in adverse selection, what is happening is the nature plays first, or nature gives its realization. Principal plays first, meaning it gives out a contract. The agent decides whether to accept it or not. If it accepts, then it puts in some effort. If it doesn't accept, the game is anyways over. Now, adverse selection is sort of like saying can we have a way so that the player reveals their nature, or in a way, this is in a mild way, you can see a parallel of this idea with the interview process. A candidate comes for a job, the managers will ask technical questions, they'll ask behavioral questions. All of those are to decide whether the particular candidate fits or not. And in the process, they're just trying to get to understand what type of a worker we are getting if this person is to join our company. Or, in other words, if we were to take an example, so let's say there is an agent with two types, one is efficient, the other is not efficient. Then they'll both have a cost of producing some output. Let's say the output that they're producing is same, so let's say they're both producing Q. One produces theta bar of Q and the other produces theta underscore Q. Let's say this is the efficient one, meaning this cost is less, it sort of like wastes less time or something of that sort. So the idea would be, whatever the principal is doing in the part of coming up with a contract, would want to make sure that the contract is designed in such a way that it gives them an incentive to reveal who they really are and choose the contract that fits their profile, not to go for something too high level and not be able to produce, not be able to give required outputs. Rather, go with something that they can handle and at the same time get appropriate wage for it. So that's what is happening here. So one example is, the agent suppose produce the following outputs. This is for the efficient player, this is for the other player. So these are the contracts, the two option contracts. Now let's assume the players actually can see the two contracts, the agents can see the two contracts and choose between them, and they both have a participation fee. The participation fee would just be whatever P that they would get minus the cost of the output. This should be greater than theta, and similarly the other one. So you can think of this as a salesperson trying to take number of hours or amount of petrol required to roam around the city to get a few clients. So like, how many hours does it take, or how much liter of petrol does he end up spending in the process of getting one client or some number of clients? That could be what is being captured as this Q, either of them depending on whichever agent it is. P is kind of like what pay they get at the end of it. So whatever pay they get should be more than whatever they end up spending in the process of getting a client or whatever. For them, there should be a positive thing. So that's what is this participation amount. So now if the agents had access to both these contracts and were to decide how to choose the contract, let's say we talk about any one of them. Let's just talk about this one. Let's talk about the inefficient player. So what this inefficient player does is, his type says that he ends up requiring this theta. Which player am I talking about again? Okay. He ends up requiring this theta bar conversion rate from number of hours he spends to number of clients he gets. So with this conversion rate and the amount of efforts he has put in, this is the payout he would get if he chose this contract. But if the contract itself is designed in such a way that, according to by knowing that he's actually inefficient, this is what he would really be getting. If this is to be considered, then the only thing is this should be higher than this. If that happens, then the player, even the inefficient player, would prefer just choosing this contract itself, which is what we want them to choose. So in a way they reveal their true type. So what is happening in this example is the player, so the inefficient agent here, even if he bluffs and thinks that he can do this much or produce this many clients at the end of a month, if he can't, then this may not satisfy the participation constraint, and that becomes a problem for him. That is something that he will know, and if he knows that, he's unlikely to choose okay, he's unlikely to choose this contract. In fact, rational means he will choose this contract and hence reveal his type. And similarly, the other agent would prefer choosing the contract that suits his efficiency. If he's efficient, he would rather say, I can produce this many number of clients in a month and hence get a certain kind of pay, as compared to this scenario. So this condition, this was the participation constraint. Now this condition sort of tells us how to design these contracts, these menu of contracts, and this is called incentive compatibility. If the players decide to take the job, this will ensure that they stick to the contract that is appropriate for their type. So if it's a very hardworking person, they should go for a job, they should go for a contract that requires them to work hard and hence get a good pay, instead of taking a job that doesn't require them to put in the same amount of effort and get accordingly a lesser pay. And that's the idea of what is adverse selection. It's basically bringing in a way so that the agents reveal their type, and hence in the process, because they've themselves revealed the type, now the principal gives them the appropriate contract, or they're basically choosing the appropriate contract according to their type. So there are a few nice examples of this. One of them is designing auctions. So typically when people designed auctions, in fact I have one example, but we'll not go into much details of that, but just surface level we'll just look at it. So when people talked about auctions, it would be, there is a seller planning to sell an object and get some amount for it. The person who is selling would have a certain value in mind, so they would want whoever buys it should match that, or definitely have more than that. The person who is buying would want to buy it at the lowest possible price that this can be bought at, and hence for him it will be valuable, because he would have a sense of a value of that product and he would have to decide what to bid for. So typically what used to sorry
Yeah, I'm audible. Actually, sorry, I was speaking before, but there was an issue with the mic. So,
yeah
I had it out actually in the previous page. If you can go up a little,
yeah, sure.
or if you can complete the report, that's also okay.
Okay, so I'll finish what I was saying about auctions and then I'll go up. Okay.
Yeah.
So earlier what used to happen was, there are two things. So each agent has to pay an amount to get the item. Suppose there's just one item. The agents are supposed to bid for that item. Let's assume it's a closed bid, so the bids are not revealed to the others. It's just some amount everybody chose simultaneously. Then it's to be decided what price should be paid for it, because typically what would happen is it would go to the person who bid the highest, but it is very much possible that the one who bid the highest actually sort of overbid from whatever was his own value, or maybe just a little bit under his value, so that he gets the item, because in reality he wants it more than what he's willing to pay. And hence what happened actually was, it was realized, I think it was Meyerson, I do not recall, sir mentioned it, Anyways, it turns out that this particular way of picking the price of the item was actually not incentive compatible. On the other hand, what was incentive compatible was uh, the agent who won was the same agent who made the highest bid. But what he actually paid to get the item was to match whatever was bid by the second highest player. What happened in this scenario is the agents were forced to reveal their true type. So if the gap between the highest and the second bidder is very less, then that means they were very close enough. It could have gone either ways. But if there is a huge gap and this person is paying less for this agent, it's actually a better thing. So he's more likely to bid at his true value than lower from there, because if he lowers, he might lose it to this second bid person, and he anyways knows that he's not going to have to pay the amount that he says. He'll pay the amount of the second highest bid, so he's likely to sort of push his bid value towards his thought of optimal value. So in that sense, uh, the true type will get revealed, and this turns out to be incentive compatible. This one, I've not written down the details of this though. Yeah.
So both, so the so I using it, the ideal should be that it should go to the second highest bidder.
Not the ideal. This is what is incentive compatible. Incentive compatible is basically saying that the game is designed in such a way, or the principal has designed the scenario in such a way that the agents, now there is not one agent but there are multiple, they reveal their types and they get what they truly deserve. If suppose I was somebody who really valued item X, and for me item Y was okay but not something that I valued as much, it's better that I get the item that I value the most. If my valuation of it is actually more than everybody else's valuation and my bid is accordingly, if that happens, then that object should go to me. That was the idea for auctions.
Mhm.
So to do that, this idea was applied. Make the agents reveal their type. In a way, indirectly, that they're revealing their. So in this example, they're revealing their bid without actually revealing the true value that they think is of the item.
Okay.
Okay. Yeah.
And
You had a
like
question.
yeah, so basically what I don't understand is that what exactly is this value P minus capital Q?
Oh, okay. Yeah, I was giving an example of this only earlier. So you can think of an example. So think of a salesperson deciding to say this theta is the number of clients that they get.
Okay.
Clients that they get per hour, let's say. Q is the number of hours this person works or talks to people or goes to client or however you
So
want to
Q
mention.
is effort.
Yeah, Q is effort.
Okay. And capital Q is the efficient output.
Yeah. And this object, this Q times theta, is the cost of putting that effort. So you can think of this as being something like how many hours did he put to get something out of it. Or rather, instead of thinking of it in terms of hour, maybe think of it in terms of transportation cost to go to.
Okay.
So on top of this, maybe there's like a function that adds that cost, converts it into some cost. So this theta is actually that cost.
Okay.
Transportation cost per hour when meeting clients. Okay, so what you'd want to do is, let's say every time he goes to talk to people, he gets an allowance on top of his wage. He gets an allowance, let's say. So he would just want to make sure that the allowance that he gets should be more than the cost he ends up spending in the process of going and talking to people.
Right.
And at the same time, get a client in the process. Not like not get a client at all. So this is that participation constraint. Here what we are saying is, let's say the two contracts says, if you meet this many number of hours, or maybe this could be converted into number of clients, however you want, sorry. So if this is the number of hours you're willing to spend on actually talking to people or actually going and visiting different potential clients, then this is what we are willing to pay you. But if you're willing to put in more effort, and instead of 9 hours common, if you're willing to give 11 hours a day, we're willing to pay you this much. These are the two different contracts. Now these values, p bar, q bar, this p hat, q hat, all of these values need to be such a way that the agents choose the contract that was meant for them. The player, the agent who is a little lazy and a little inefficient, he should go for lesser number of hours, and hence lesser expectations of target and so on, and hence lesser pay also. On the other
Right.
hand, this player should, because he's a hardworking player and efficient on top of that, should choose a contract that pays him accordingly, and he's willing to do that amount of work. So this is captured through this incentive compatibility condition.
Right.
Okay, perfect. So this covers adverse selection. So like I was saying, so this is an example of a seal bid auction. So consider there's a seller who wishes to sell some item through an auction. Let's say there are two prospective buyers who bid for that item. The buyers have their individual valuation, so they would have some amount of price for any particular item. These valuations could be considered as the type of the buyer. So this, whatever this valuation is. Here the game consists of two bidders, namely the buyers. So n is 1, 2. The two bidders submit their bids, so they give the values b1 and b2. So this is, the item goes to the person who does a higher bid, and a tie is resolved in favor of bidder 1. So this is how the winner is decided. So this is the standard part. The next part of talking about auctions is to decide what to do with the price that they have to pay. So the two scenarios that I talked about above. So if it was the case with highest bid, then utility, okay, so I'm going to write it as utility for player 1 and utility for player 2. The utilities obviously depend on the value of b1 and b2. Utility for player 1 would be b1 or 0, and similarly this would be b2 or 0. And when does this happen? He would be paying b1 if he actually acquired the item, otherwise why would he pay that? So this is if b1 is actually greater than or equal to b2. In case of equal to, because it is going to bidder 1, this is okay. This is in the opposite scenario. b2 will be the one having a utility, and that could be if the bid of b2 is strictly higher than the bid of b1. Else he doesn't get the item, so for him the utility is 0. Either you can think of the utility as the price that he has to pay, or if you don't want to think of it in terms of price, you can think of whatever valuation he had. He would have had some valuation. From that valuation, how much did he end up having to pay? You can write it in either way. So I have written it in terms of the cost. Here we are assuming that there is no cost of entering the auction itself. This is the case with highest bid. If we were to go with second highest bid, then there are only two bidders, so they pay the value of the other one. So here he would pay b2. b2 is lower and he's paying lower than that. Here b1 is lower and he's paying accordingly. This is what second highest bid means. So now you can try writing out what incentive compatibility would mean in this case, and hence see if you can argue about the statement here that this one is incentive compatible and this one is not. Which is basically you'll need to bring in their own true valuations, and only then you'll be able to write out what the utilities are. In terms of cost, it'll not be very effective. But either ways, yeah, this was just motivating. Like I said, this is just surface level. I'll not go into how actually incentive compatibility is written and all that. Okay,
Yeah,
let's
got it.
continue further. Okay, so now this is the part about communication. So far we've talked about what happens if a contract is suggested from a principal to an agent, and in the process of after accepting that contract, how much effort would the agent actually be making. The other extreme of the scenario could be if the agents were just in straightforward direct communication with each other. Which is like if an agreement is signed, they have decided that they're actually going to stick with it. They're basically deciding
Right.
whether to so now the choice only goes towards deciding whether to actually sign the agreement or not sign the agreement. But once they decide to sign the agreement, that means they're actually going for it, that exact amount. What we saw earlier was even after signing the contract, they may not put in the efforts that they sort of signed up for. These are the case with binding contracts in a way. Okay, so this is one example. Okay, this is the motivating example. So consider this game of prisoner's dilemma. Let's say both the players are maximizing. Hmm. So in this game, we already know that this would be the Nash equilibria for this. Uh, Simply because 6 is greater than 2 and 1 is greater than 0. So this is actually the dominant strategy. So it's ultimately left for player 1 to choose between these two, and hence player 1 would be choosing this, and this would be strongly dominant Nash equilibrium. Okay, now suppose we bring in these binding contracts. So before we talk about binding contracts, the first question is what does it mean to even talk about communication, and how do we model it? Communication means that I am saying a word, in response to that you're saying another word or maybe a sentence, and this sort of goes on. So in a game, each of these words can actually be thought of as an action. So do we consider each of these actions and consider, okay, this is one word I've said, this is the second word this person has said, and model it? But if we were to actually model it that way, then the length of the communication that is happening would matter, and that would become very difficult to handle because this length is going to be a variable object. In any way, this is going to be very difficult to model in this way. Rather, it was modeled by just looking at the outcome itself. So at the end of the communication there'd be some outcome that would have happened. That okay, they would have decided, if once we're in the game, we'll just toss a coin. Head if the coin gives a head, we both do this. If the coin gives a tail, we both do this. Maybe that's the outcome of the conversation. So they basically entered into a contract, and this one is what we're talking as a binding contract. So if that happens, let's say this is one scenario. Yeah, so this is outcome of one of those communications. So they say they entered into a contract and they agree to play x1 x2. So they agree to play this one if both of the players sign the contract. On the other hand, if only one player signs the contract, then what will each player play? That also is written in the contract. So it's sort of covering all bases. So it's covering all the contingency plans and so on. So now what we can do is we can just make the static game for this scenario, which is that we add the decision of whether to sign the contract or not. And that we can just do by saying the following. If both of them decide to go for the contract, then the utility is 2 comma 2. This is x1 comma x2, which is this one. On the other hand, if suppose player 1 decides to accept the contract, so it's this scenario, but player 2 doesn't, what should he do? He should just play y1. So his utility would be just this copied. That's what the contract said. Similarly, if player 2 is the only one who agreed to play the contract but player 1 didn't, then what would he do? This is what he would do. And then we can solve for the Nash equilibria of this game. So if you actually do that, you will see that there are two of them. This is one, this is from the original game, and this is the other one. So now if they were to actually look at the values of these two and decide on the basis of that, and since both the players are maximizing, this is a better Nash equilibria. I know that's not how it is done, but if they were to do that, and if they, on the basis of that, they were to decide, the choice for them is that they should sign the contract. Okay. Now this can be extended further to add one more scenario here. So this is another contract. So this is one part of the clause. The other part of the clause is this copied. Maybe I'll copy it. So what, this is a second contract. So if both the players sign, they will, what they'll do is they'll toss a coin. If they get a head, they do this. If they get a tail, they do this. So what happened here? They assign probabilities to some action profiles. By assigning these probabilities, in short, what they're saying is they have given probability 0 to this and this. They have given more probability to these two. And hence you can just take the expectation of these and that gives you the utility value. And that's actually why here it's a 3 comma 3. Clear?
And like, so this is 3,3 because we're taking the expectation over those two. But the one common beside that, why is that? And like the other values, like this 6,011.
So I think this was not explicitly said, but this was assumed. This statement from the previous contract still holds. So if only one of them signs, then they play y1 and y1 or y2 respectively. So then they just copy this. Y1 is what? Copied. and this copied. So this is by assuming that this contract S1 happened before. So this may
Okay.
be, either you can think of this as a extra clause. Maybe they're deciding whether to consider this clause or not, whether to, or this is an extra contract. If it is an extra contract, then we need to specify what should happen to the case where one of the player doesn't sign it. So this kind of a statement is needed. This, I think, was assumed. It maybe wasn't written, maybe said only. That's why it got copied here and this one here. Okay,
Right.
so you
Okay.
can check again. You will get equilibrias here. Now one equilibria is not pointed out, which was this one. Mostly because this is mostly because this is weakly dominant. No, sorry, this is weakly dominated as compared to these. If you compare these two, this is weakly dominated. If you compare this and this is again weakly dominated. So by that, it's better not to eliminate it, but you can eliminate it in certain cases. So if you were to eliminate it, this would not exist only, and hence these are the only two you will get only by those arguments. But in reality, this is still a valid Nash equilibrium. Okay, and with those arguments, what was said was these are the two pure strategy Nash equilibriums, meaning it's good to sign this contract, comma this contract, both are valid ones, or you could even go for adding one more layer on top of it and being like, okay, we will both sign these contracts with probability half, both of them with this, both of them with this. And then you can calculate the expected value with that as well. So yeah, this next part I wanted to cover, but looks like it's not going to happen. But anyways, so what we have been talking about so far is one way to think of these contracts is to think of them in terms of some sort of a probability distribution. Like here, there was a coin toss that gave a probability distribution to these utility values, and what we did is in the process of getting this 3,3, we just multiplied the actual utility value with the probability assigned for this profile, with the probability value assigned for this profile, and also the other ones for which the probability was actually 0. There is a name for this kind of a way of thinking. The name is correlated strategies. This, okay. So this is one way of thinking about how to enforce contracts, or you can say it in the other way around also, that correlated strategies are the ones that are possible with contracts, or if you are enforcing a contract, it is something you can call as a correlated strategy as well. So what happens here is, let's say there are a total number of players n, a subset of those decide to sign a contract, any one contract that we are talking about, for example. Then for all those present in that set, the ones who are signing the contract, let's just call them x of s. So for those, there will be some sort of a probability distribution that they'll have. If you see if you see 1 on a dice, this is what we're going to do. If you see this on a dice, we're going to do this, and all of that. That's the binding contract is what they're going to create, and that will have some probabilities. Either those probabilities could be just simple zeros and ones, or it could be some distributed probabilities across the set of actions that they're talking about. It's actually over the whole thing, but they can possibly assign 0 probability for a particular action profile as well. Okay, so this is this is the, what is x? Okay. X1 to xn refers to the set of actions of all the players. So this is the action of all the players that entered into a contract. This is all the players apart from I. So let's say if a contract is signed by a subset of the players, then it puts a distributions on the actions of that subset of the players, and this is how we denote it with this delta of excess. A contract is basically given as some probability distribution picked from this set of probability distribution, so valid probability for all those players. So any distribution U is called a correlated strategy if it actually refers to the scenario where everybody is entering into a contract. If everybody is entering into a contract, then there are no outliers, so everybody is a part of it. And if that happens, then what we are ultimately doing is we are looking at expected utilities, and the expectations are with respect to these mu values. Meaning, we could write, so for example, if we were to write the utility of player I for the distribution mu, then you'd say that this is the utility of I for an action X, and you'd multiply it with the probability of that action X. X is referring to a profile, not just one. Yeah, it's referring to the profile, so all the players. So what actually happens is that the set of payoffs that are achievable by contract signed by all players is this. On the other hand, if not all players are signing the contract, then what happens? Then you can think about these security levels, these VIs for each player. So let's say the player in question is a maximizing player. So what he'll do is he'll maximize this expected utility. Here the expectation is over, or the, yeah, okay, so the expectation is over all the other players who, let's say, are a part of a contract, and I is not a part of the contract. Then this is his security level. So this is like saying what's the worst that he'll encounter if he decides to not be a part of that security level and he does whatever he wants. So if he does X, if he chooses any action X, then this is the best he would have gotten. But other players are also doing some sort of a randomization on top of those actions, their own actions, action profiles. So if we take the minimum of that, then that's the worst utility this player would have gotten in the optimal scenario, obviously. So this serves as a security level for player I. Since we are talking about security level, we know that the same thing could have been talked in a reverse manner also. Reverse manner in the sense that what if player I was the one who was entering into a contract, but all the other players are not? Then what is the utility? What is the best case scenario that he could have encountered? Whatever action he's taking will be an equilibria concept only if these two match. The min max and the max min match. That's why they've been taken to be equal.
Right.
So what this is basically saying is utility of any player for UI will just be greater than the security level. For that kind of a U, whatever you get, that forms okay, that is what we are calling as a correlated strategy. Wherever for whatever strategy, the utility of player I is better than the security level, or maybe equal to that security level, but this has to be true for all players. And if that happens, then this can be thought of as a solution concept. Talking about correlated equilibrias. We've not come to equilibrias, but we will. I think that's in the next lecture. And this was the last statement made, that the set of utilities that can be uh, achieved by contracts is actually exactly this, where these mu's are correlated strategies. Notice what we had here. This object is an example of a correlated strategy. The correlated strategy is playing half for the profile x1 y1, playing the profile x1 y1 with probability half, and with the other probability playing this x1 y, what have I written, x1 y2.
Except for two and
Yeah, okay,
one.
this should have been 2. This is the result of a correlated strategy. Okay.
Right.
um, don't worry, this correlated thing is going to come up in the next week also, so we'll go through this peacefully next time. Yeah, with this